Welcome Year 11s to this next video about Chapter 6. As you can see, we're looking at the intercept slope form of the equation. So far up until this point, we've covered a couple of key skills. I've looked at sketching using a table, sketching using the calculator, to assist, adjusting the window settings, getting a table on your calculator, and then also the slope of the line. Now, what we're going to do is bring together this into our intercept slope form. I'll say that correctly at some point. Intercept slope form of the equation, because this is the form of the equation we're going to be using in this subject. And in further maths as well. So instead of saying y equals mx plus c, we tend to use this y equals a plus bx. So I'm going to start just exploring that, do a little bit more sketching in this video, and then in later lessons we'll look at forming the equation, and then we'll get to looking at the real life scenarios. That's where it gets a little bit trickier, I guess. So in this form of the equation, we actually write the intercept, the y-intercept first. So it's already labelled here for you, but I like to just highlight as clear as possible that a, or the constant, we also call this the constant, is the y-intercept. And that's because when you substitute into this rule an x value of 0, that term cancels out. And so all you'll be left with is a y value equal to a. And that's why when we write the coordinate as well, we'd write it as 0, a. Now keep in mind that can be negative too. The slope, of course, which we've looked at in the previous lesson, the rise over the run, is always going to be the coefficient of the x term. So it's always this number being multiplied by x. Now, you've done this for many, many years now, so I'm really just telling you a lot of things you already know, but it's just, these are the essentials. I'm just trying to highlight to you what you really are expected to know at this level. So here we have just a simple warm-up question. Write down the y-intercept and the slope of the following. Now you'll notice that with each of these, we've got either positives or negatives. So just make sure you never leave out one of those positives or negatives. I'm just going to write A and B because that's our y-intercept and then our slope. But keep in mind too that you can also write your y-intercept as a coordinate. Sometimes you're asked to do that. So with this first one, I can see that in the form y equals a plus bx, I just have to have a look at what my a value is. It's -5, and my b value is 6. As a coordinate, if I was listing the y-intercept, that would mean x value of 0. That's always where the y-intercept occurs, and then my a value, which is -5. For this next one, A would be a +7, but if you look at B, it's got a minus in front of it, which means that our B value is actually -2. Again, I'll just convert this one to a coordinate so that we've well versed in that. Here we've got our A value -3, and B is also negative, -4. And finally here, we've got an A value of 2 and a B value of 5. There we go. So we do need to be able to, especially for worded questions, some that will come up against next week, we definitely need to be able to identify very quickly the gradient and the y-intercept, because we're going to be interpreting them in the context. So this is going backwards now. What if you are given your y-intercept and your slope and you're asked to form the equation? So remember, we always write the equation in this form. So that's your little, I guess, your structure. You don't have to write this. I'm just going to do it underneath for those who find it helpful. So if we start off with this one here, I'll go y equals, I'll then start with my y-intercept, and I'm told that the y-intercept is 4, and then it says slope of 8. So instead of b, instead of plus b, I'm going to write plus 8, and then my x. So y equals 4 plus 8x would be the rule. For this one here, same deal, be -6, but that's plus 3x. I've got +2 But when I've got a negative slope, I don't write plus, never do this. That's really bad. Or it's not technically wrong, but it's not good, what we call mathematical conventions. It's not the way that we would write it. It's not simplified, in other words. So we'd write take away 2x. And then this last one, y equals, got a y-intercept of -1, slope of -4. There we go. So now that we've had a bit of an exploration of that, I will be getting you to try the exercise. Now, I just noticed as well that within that exercise, they get you to practice a little bit more sketching. So that's why this page is in there. If you're wondering why are we going back to sketching when we did that in a previous lesson, this is one other way that you can sketch, and this is probably the way that you'd be more familiar with prior to using your CAS calculator, because the CAS calculator, you can get your sketch really, really quickly, and you're basically just copying your line onto your sketch. But if you didn't have that, this might be actually a faster method even for some of you. So I'll just show you when you are sketching from an equation. So say you've got your equation y equals a plus bx. It's not always necessary to grab out your calculator, put the graph in, have a look at what points it passes through. You really just need 2 points. And obviously, you'd look for any intercepts if you can, but sometimes sometimes you're just asked to sketch the line showing the y-intercept and the coordinates of one other point. So that's what I wanted to show you, coordinates of one other point. So if I do it with these 3 here, and it doesn't take very long, as you can see, which is why the calculator is not really needed, I've got my axes already set up. Looks like I've got from -10 to +10 on each axis. And I've got my rule over here. So first of all, I would establish what my y-intercept is, and therefore what is the coordinate that this line passes through. So once you've got that, you'll plot it on your graph. And then all I need is one other point that this line passes through. So all I will do is use substitution to find where is the graph when x equals 1. And I just chose x equals 1 because that's a really easy number to calculate with. So that's going to be 3 plus 4, and that gives me 7. So when x is 1, y is 7, so that was 3. Like so. And then I will connect them with my straight line. So I didn't do a very good job. Just adjust that a little bit. I'd label those two. So it says clearly showing the y-intercept. You have to label it. And the coordinate of another point. So that's what I got down here. I had x equals 1, y equals 7. So that is another way of sketching. If you are only asked to show those things, then you might find it a lot faster, more efficient just to do it this way. Just a note though that if you do this with questions from your text, when you're checking your answers, they may not have chosen x is 1. They might have chosen a different coordinate, in which case you just need to check that yours matches. Say if they chose x is 5, just check that x is 5 matches with your equation. Obviously it will, but you should just, have a look anyway. Have a look that your gradient is going in the right direction compared to theirs, and have a look if the coordinate that you've got looks accurate on their graph. It's a bit annoying when you're trying to correct your work with these sorts of questions. Just do a couple more with you before I finalise this video. So a is 9, so that gives us a coordinate of 0, 9. So it's right there. It does have a negative gradient because it's got -10, so I know the line's going to come down this way. I'll use x equals 1 again because we should be able to fit that nicely into the graph. So 9 minus 10 times 1 is what I'm doing. So 9 minus 10, that gives me -1. So I've got this point, 1, -1. All right, so this one's really, really steep. Try and fix it up a little bit. And of course, always label in those points. So it's very important you do pay attention to what you've been instructed to do, because a lot of the time if there's an intercept, you should be showing an intercept, which you can see has happened here. But since I was just instructed to do one other point, that's all I've done. And finally, y equals 2x. Now, something like this looks a little bit different because you'll see I don't have my constant term. If you don't have a constant term, that just means that it's 0. This is the same as writing, I'll put the constant first, 0 plus 2x. That's exactly the same mathematically, which means that a must be 0, meaning this one goes through the origin. So you'll see that any graph that goes through the origin will not have that a value. So if I just want one other point, again, I'll just go with x is 1 because that's easy. So 2 by 1. So this goes through 1, 2. So like that. And then we connect it. Notice too, I am extending the line right across the grid. I'm not just connecting these 2 points together because the line doesn't go just between those 2 points. The line continues really forever, which is why we put these little arrows on the axes. All right, so 0, 0 and 1, 2. There we go. What you can also do, just to get used to it, is, put your graph's equation or label it next to the graph. Mainly because when we start doing a couple of graphs on the same set of axes, we are definitely going to need it labeled. All right, I'll stop there. So you are going to do an exercise where there's a little bit of this sort of thing. So you're identifying the y-intercept slope or writing the rule, and then you're going to just have a little bit more practice of the sketching. So I'll leave that there. In the later lessons, we'll look at developing this equation from 2 coordinates rather than from the intercept and the slope.